Okay, I just got the okay from Bill that we can begin. First off, I'd like to thank everybody for attending this webinar today. And although I have no idea who I'm speaking to, and it's going to make things a little bit difficult, I hope that you find something here which may help or influence your decision as to whether kilns or heat treating chambers are a good idea for your business in the coming future. For those of you who don't know me, my name is Scott Jeffross, and kind of about my background a little bit. I'm the operations manager at Kitchener Pallet Services. I'm trying to move my slides ahead here, and it's not seeming to want to work right now, so bear with me. I've been in the pallet business for about 10 years now, and we, at Kitchener Pallet, entered into heat treating around 7 or 8 years ago. At that time, we developed a heat treating chamber, which we have now brought to market. Hence, you see WoodSave under my name, and that's the company with which we represent for chambers. I'm not here today to promote my chamber specifically, more so to give you some information to help you make a decision as to whether chambers are a good idea for your business. Bill or Stephanie, could I get some help here trying to figure out how to move the, there. Sorry, I got it. Sorry about that, everybody. Okay. There's quite a few things to move through, and there's quite a few variables with different chambers, and I'm going to just try and touch on things very briefly and give you a brief background of Chamber Technology 101, just some of the basics. Some of the things on how we have to operate here in Canada versus the U.S. Most of our publications refer to U.S. criteria, and therefore it gets confusing for some of us operating in Canada. One of the biggest things is determining the cost to you of heat treating. We're going to show you how to figure that out. Some other considerations that you have to look at when purchasing a kiln or chamber, site-specific evaluation, and hopefully we'll have some time for questions at the end. So I'm going to try and breeze through because I think the questions are probably the most important part. So first off, just basically out there on the market, there are dry kilns and heat treating chambers. Dry kilns have been around forever, and the theory behind them is using heat and air over a long period of time to remove moisture from wood to bring that moisture content down. When ISPM 15 came about, it was realized that the dry kilns could theoretically reach the 5630 criteria or Canada's PIO 7 criteria. In a lot of cases, though, because they're vented and they're used for drying, it's a challenge to meet wet bulb requirements, and a lot of those systems need to have moisture added towards the end of the cycles. Heat treating chambers are generally not vented. We want to keep as much humidity in them as possible to allow for proper transfer of heat into the wood. And they're designed basically to heat wood quickly, especially in the U.S. where core probing is allowed to reach that 56-degree 30-minute mark in as quick and efficient a manner as possible. A couple of pictures that I'm going to show you here. This is just to give you an idea of kind of how air movement works inside of a chamber. You'll see a heating vessel, air movement. In that open area, you can imagine your pallets or your stickered wood products there. To the next slide, this is just an example. If you are treating stickered lumber as opposed to pallets, you will need to allow for air to pass through, and it's a consideration when you're looking at the volume necessary in your chamber, because you do need to allow for that airflow to be able to meet the criteria. Something that we have unique to Canadian operations, different than the U.S., is a wet bulb. This is a picture of a very simple wet bulb. The theory behind a wet bulb is that air will pass across water. There is a wick that dips into the water. It artificially cools the probe and creates a wet bulb depression. This is very key when we get into talking about PIO 7 in a little bit, because this simple little bucket here actually controls your heat treating cycle. Core probes, which we'll talk about as well, are, as you can see from this picture, plugged directly into the thickest part of the wood, and they monitor the internal temperature of the wood or of the pallet. They typically use the thickest piece of lumber within your chamber. In the U.S., 3 of these probes are used to monitor the charge, while in Canada we use 1, which will signify the start of the charge. So I've covered a little bit here on the U.S. versus Canada. Heat treating in the U.S. is run and regulated a little bit differently than Canada, and therefore some of the kilns available out there may not be tailored for Canadian operations. In the U.S., as mentioned, 3 core probes are plugged into the product throughout the chamber. They're monitored. They hit 56 degrees Celsius. They're held for 30 minutes, and your charge is complete. Therefore, you can hear of different kilns cycling in an hour to an hour and a half and meeting ISPM 15 criteria. In the U.S., the ALSC, or the American Lumber Standards Committee, oversees the heat treatment. All of the inspection bodies are very much independent, and they work on 12 inspections a year. In Canada, we're just a little bit different than the U.S. The CFIA still essentially regulates, and they've provided us with a document called the PIO7. The PIO7 is essentially your heat treating Bible, and if you choose to operate a kiln in Canada right now, you're going to work with either the PIO7 or have a site-specific evaluation done. The PIO7 involves ambient air temperatures, the wet bulb which we showed you, and a core trigger start, and then a series of time criteria based on the lumber thickness and size that you're treating. The link down below will take you to a copy of the PIO7. I'm going to touch on a little bit more of it here as it pertains to the treatment of pallets. Schedules are something that you'll hear a lot of talk about, and they're the operating parameters found in the PIO7 or given to individual sites by a site-specific auditor. What these schedules refer to is the time and temperature that must be met in the treatment cycle to achieve the compliance for Canadian regulations. They vary by lumber species, they vary by lumber thickness, and if you are going to operate and treat with your chamber a multitude of sizes, you're going to need to be familiar with multiple cycles. They can be influenced by the start temperature, which must be 15 degrees Celsius, and the level of wet bulb achieved, and you can also vary the time by playing with levels of wet bulb, the top end of that temperature, etc. Site-specific evaluation, didn't put any verbiage, so we put a picture of some nice pretty blues in there for you. Site-specific evaluations are available to operators in Canada, and what they do is they help to detract from the length of time that's typically found in a PIO7 cycle. We're going to discuss option A of the PIO7 coming up next. Site-specific evaluations, what they do is if you have a chamber, you'll bring in an approved auditor, and there's a few of them in Canada, and they will test your chamber against the PIO7, and they will determine at what point in your chamber the proper criteria is met. We found that with site-specific evaluation, you can reduce your run times by up to 50%, and we hear varying reports of costs ranging anywhere from about $5,000 up to $12,000 or $14,000, depending on the number of cycles that you're going to get. It's a key consideration when buying your chamber. If you're going to establish the volumes that you need to run, the amount of cycles that you are going to need to run to be able to meet your customer demands. Because of the PIO7 cycles taking the better part of the day, site-specific evaluations will sometimes allow you to be able to squeeze 2 charges, 3 charges in a day, as opposed to the 1 that you would be forced to have with PIO7. Now, the PIO7 is fairly easy to understand. I'm going to highlight option A here because for most of us in the pallet business, we're going to recognize a softwood 4840 with a 2x4 stringer. This is the shortest and simplest cycle that the PIO7 has. Again, if you're considering a chamber, this is what you're going to have to know. Under option A, the minimum required heat treatment time is 6 hours and 26 minutes from the time the initial core temperature of the pallet is 15 degrees Celsius. Meaning if you're going to start your charge in January and your pallets are stored outside and they're -5, you're still going to have to heat that pallet load up until 15 degrees Celsius before the 6 hours and 26 minutes commences. During that cycle, the PIO7 calls for you to watch for and monitor both ambient temperatures as well as your wet bulb depression. And your wet bulb actually must meet 60 degrees Celsius, which will start a timer for 2 hours and 3 minutes. At the end of that 2 hours and 3 minutes, it must exceed 63 degrees Celsius. All in all, what it means is within the 6 hours and 26 minutes, you need 2 hours and 3 minutes of wet bulb runtime that is above 60. Typically, in most chambers that I've seen, your wet bulb is anywhere between 10 to 20 degrees Celsius, different from your ambient temperatures, and that depends on location, size of the chamber. The PIO7 schedules increase in time and temperature requirement from there depending on the lumber thickness and species. When we get into mixed runs or hardwood runs, we need to evaluate which category of the PIO7 it falls under. Primarily, items falling under option A are your softwoods, and option E is the most common schedule for hardwoods. This kind of gets into more of the meat and potatoes here when you're operating a chamber and you're considering a chamber for your operation is how much is heat treating going to cost? Pretty easy in Canada because of the PIO7, and it's basically telling you exactly how long you need to run. So you're going to need to calculate the amount of energy in the time specified in the PIO7. So I use a fairly simple formula for figuring out that cost, and it calculates energy only. You're going to have increased costs in stamping movement, but your shop efficiencies are going to dictate those. Hard costs can be figured out pretty much as follows. I'm going to use the electric kiln here just because the numbers are fairly simple. So in an electric kiln that's drawing 60 kilowatts per hour over a runtime of 6 hours and 26 minutes, the cost is fairly simple. 60 kilowatts times, I use 15 cents per kilowatt delivered in Ontario. Depending on where you're operating, that may be a little bit different. I believe Quebec is quite a bit less, and maybe the West is a little bit less as well. But it'll give you an operating cost of $9 per hour. We're going to take that $9, multiply it by the 6.5 hours that you need to run your PIO7 schedule, giving you $58.50 in energy to run the cycle. Based on the number of pallets in the chamber, I'm using 400 here. It gives you an energy cost of about 15 cents per pallet. That number is going to vary according to the efficiency, the size of the chamber that you're operating. And if you're going to be using or looking at gas chambers as opposed to electric, you still need to factor in your electrical costs as well as the consumption of cubic meters of gas per hour in that cycle as well. I would think the numbers should be available from the different manufacturers, but usage is also going to vary with gas by location, ambient climate, relative humidity in the chamber, altitude, a couple of different things. These figures, when we look at the cost to operate, again, this is just your bare bones hard costs. You really need to evaluate your setup, the amount of movements that it's going to take to load and unload, stamping, administration, inspections and inspection fees, and these all need to be incorporated in before you can determine your overall operating cost. Here, just bear with me for 1 second here. Having the experience in operating a chamber for many years and building chambers and also running a pallet shop, oftentimes I've looked and wondered, do we really need a chamber for our operations? In my case, it's definitely yes. We not only retreat repaired pallets, but new pallets, source alternate materials, and do heat treating for other companies. So for me, it's become a very integral part of our business. Some of the things that you need to consider is retreating repaired pallets. And in Canada, we're allowed to repair under the 1/3 repair rule. Hopefully you're all familiar with that. where if you take a pallet that has an existing stamp on it, if 1/3 or less of the components of that pallet are broken, they can be replaced with heat-treated lumber. That pallet can be moved on down the line and sold as HT. The other line of thinking is just repair everything, don't worry about that, and retreat them. You'll need to be able to evaluate your costs one versus the other. I am very pro heat treatment because of the traceability of the product, and it's a heck of a lot harder to cheat that than it is doing it with the 1/3 repair rule. And also, I like my guys to be repairing pallets and not thinking about segregating different products, segregating different things. The less they have to think, the more pallets they're going to repair in a day. So therefore, to me, in my estimation, retreating repaired pallets is the way to go. It is the most efficient way, and it is probably the cheapest. You may find you have other thoughts on that, but that is kind of where I stand. Having a chamber will also allow you to source alternate species, treating green product. If you use a lot of softwood, mill run rough then becomes an option for being able to sell HT. We all know what the dressed softwood market is looking like right now, so looking at these different options, having a chamber definitely can give you a competitive edge against using these other products. Servicing your own operation and also other companies is another way that a chamber can make you money. And when we address the lack of kiln capacity in North America, if this bilateral agreement comes to an end, which we firmly believe that it will in the upcoming probably 2 years, there's a definite lack of kiln capacity, especially in Canada, to meet the demands moving forward. So it may not be for everybody, but I think there should be more operations looking to bring chambers in to be able to meet these demands, or our industry could be set on its ear. Some different factors to consider. Again, we manufacture chambers here. There are other manufacturers out there. From everything that I've seen, there's a lot of very good products there. So you need to be able to look at all the different options in there and consider which chamber is best for you. Ultimately, the best advice that I can give you, especially operating in Canada, is ensuring that your chamber is going to be PIO7 compliant. I've seen this numerous times where US-built equipment comes into Canada, it's set up for core probe monitoring, it arrives, and all of a sudden you as the operator can't use it because it's not compliant here. Do your homework, ensure that you have all of the tools necessary for your kiln to function under PIO7, or there could be delays and further upcharges. Other things to consider that we've seen over the years is bigger better. Stateside, the tendency is to look at large units, lots of BTUs, and very, very fast turnaround. In Canada, again, because of the PIO7 and the length of time necessary to treat, smaller chambers, smaller capacity, and more efficient chambers may be a better way to operate here from a price point. Chambers that I've seen as well, they operate better when they are full. So if you've gone and overbought a chamber, you're either not going to be operating it or you're going to be operating it at half full. And if you're operating at half full, you lose a lot of efficiency. Therefore, your cost per pallet is going to go up, and essentially in this operation, cost per pallet is the key. Also evaluate the cost of your site preparation and really evaluate your site as well. You're going to need to look at things like energy supply to the site of the chamber, possibly putting in a foundation, meaning you might need building permits. You need to look at the footprint of the building as it relates to your yard and your efficiency of moving product around. In a lot of cases, kilns are placed as far away from the shop as humanly possible. We'll need to evaluate how much extra driving your tow motor operators are going to be doing to load and unload this. If you're putting a permanent structure in, you'll also need to evaluate if there are any tax or leasehold implications on your property. Another thing that people don't think about are the increased inspections that go along with having a kiln on site, and you know, it may be $1,000 to a couple of $1,000s a year, depending on your service provider and whether you are getting inspected quarterly or monthly. and that, again, will depend on your service provider. But those things will all go into determining your cost of operating a chamber and should definitely be factors to consider when evaluating whether a chamber is right for your operation or not. I think I've breezed through that fairly quickly, and I hope I didn't miss too many points, but I would like to open it up for any questions that you have. Hopefully in that format we can cover anything that I missed, breezed over too quickly, or anything to that effect. So I'd like to open that up, but I don't know, Stephanie or Bill, if you can make that happen. And you can just type in your questions, and again, I'm not 100% how to do that being new to this, but fire away if they're out there. Okay, I'm just sitting here getting some prompts from Bill, and we're just going to wait another minute or two to see if any questions do come in. In the meantime, I would like to invite any and all of you that are here to contact me directly at any time, and I'm just going to put my contact information up there, the email address or my office number here at Kitchener Pallet, and I'll be happy to go into any details about the systems that we have or anything that we've discussed here. And I just had a question come up here. It is, what do I have to do to set up my site to use a kiln? Starting at the beginning, obviously, you're going to need to decide on what type of chamber you are going to get, and there's numerous on the market, and they are going to impact what you need to do to the grounds, what you're going to need from a building or a structural standpoint, as well as the movement of gas lines, electricity lines, so on and so forth. Once you have that all established and you've decided on which chamber that you are going to purchase, my suggestion to you is to contact your service provider at that point, somebody like Bill, and they're going to give you a rundown of how you're going to need to alter and change your operating manual to fit having a kiln. From there, you're going to need to contact the manufacturer, find out all of the technical data as it pertains to airflow, BTUs, probe locations, and schematics, and sorry, excuse me, the question rolled through, and add those to your manual. So those are the basic steps to set up your site. Once you have that, your inspector will provide you with a wealth of knowledge as to how everything else should operate. I had another question in as to whether this presentation is available. Get a copy of the presentation, and Bill has just let me know that they're going to post the recorded webinar on the CWPCP website, and in the meantime, we can email the PowerPoint presentation. And again, I'd be happy for anybody to contact me directly here at the office, and I can answer any more questions or go through things as needed. I'm hoping that whoever answered the question about the site setup got their answer. Okay, well, it looks like we've got nothing more coming in. So again, this has been a little bit different for me, not being able to see everybody out there and see whether I'm putting you to sleep or moving too fast. So again, I hope there was some positive information that was put forth here.